Hello, sixth graders. Today I am going to be teaching you about how to use models to multiply and divide integers. You're going to need this practice page, and on the back is a notes page, and this notes page is going to be what we start with. Now when we are dealing with integers, sometimes we use these colored counters, and I would recommend using yellow as one positive and red as one negative. For today, we are going to use both of these and we're going to record our model here. So when you learned how to do multiplication, just plain old multiplication in elementary school, we did a lot of conversations about groups. This first number will represent the number of groups, and the second number represents what is in each group. So if I was going to rewrite this as a verbal description, I would say I'm going to have 3 groups of, and there's 2 in each group. So because this is a positive, I'm going to note that this is a positive, although it's just implied. It's one of those invisible math things. If there is nothing there, it's automatically a positive. So we have 3 groups of positive 2. And then we would model that with 3 groups. Here's 3 groups. And inside of each group is 2 positives. So I can have 2 positives, that's one group, 2 groups, and 3 groups. And if I record that work, I would put 2 positives inside of each group, which gives me a total of 1, 2, 3, 4, 5, 6 positives. So my equation and my solution would be 3 times 2 equals 6. Again, invisible math says if there is no symbol, it's automatically positive. So positive 3 times positive 2 equals positive 6. Now what's new to us is these negatives. So we're going to use the same exact format here. We're going to talk about groups and what's inside of each group. And that's how we're going to model. So this verbal description would still be 3 groups of, my second number is -2, so each group is going to have 2 negatives. That would look like this with counters. I'm going to do a group of -2, one group, 2 groups of -2, and 3 groups of -2. So that's a total of 1, 2, 3, 4, 5, 6 negatives. To model that, I would still start with my 3 groups. But this time, instead of positives, I know in each group I have negatives, which gives me a total of 2, 4, 6 negatives. To record my equation, or my solution, I would write 3, which is invisible math positive, that's positive 3, times -2, and that was equal to 6, but this time they're not positives, they are negatives. Well, what would happen if I have a negative in the front? Remember, that's the number of groups, but I can't have a negative number of groups. So I would write the opposite of 3 groups of, and that's a positive 2. So I could start with my 3 groups of positive 2. Here's my 1, 2, 3 groups.
Good morning. Please stand for the pledges.
I have 3 groups, and I put positive 2 inside of each one. But then I have to remember that the -3 represents the opposite. So if this is 6 positives, then the opposite of 6 positives equals 6 negatives. So negative 3 times positive 2 equals negative 6. Now this is not the only way to do this problem. As you learned already with our properties, multiplication is commutative, which means that I can switch these two, and as I switch them, I could rewrite them. So that could also be written as two groups of negative 3. And then I would go back to the way I modeled this one, and I would model two groups with 3 negatives in each one. Unfortunately, we can't do that with this problem because I have a negative 3 times a negative 2. So using the commutative property does not help me here. So I'm going to rewrite this as the opposite of 3 groups of negative 2. Well, 3 groups of negative 2, I modeled that up here. 3 groups of negative 2 looks like this. And then I need to do the opposite of that. So I could start with my 3 groups of negative 2. And that's 6 negatives. And then I have to go back and do the opposite of that. So the opposite is positive 6. So that's negative 3 times negative 2, and that equals positive 6. A lot of times we can see some patterns in here. If you notice, 3 times 2 is 6. 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 So we're able to see that there is at least a pattern, and the numerical value of my solution is just like you've always seen it. 3 times 2 is 6, and that's not going to change if it is a negative or a positive when we're dealing with multiplication and division. So one of the things that we're going to have to remember is the numbers are pretty are easier to find than in adding and subtracting, but then we just have to figure out, are we taking the opposite of that number or are we leaving it as it was? Division is much the same, and I didn't want to show you too much with division, but let's take 12 divided by negative 3. To model this is a little bit different because we're still talking about groups, but my groups is going to be my second number. So 12 is the total pieces, and the number of groups is going to be here. So I would say 12 total split into the opposite, because it's a negative, the opposite. I'm going to circle the opposite because a lot of times that's the hard thing to remember, is if I have the opposite circled, then I might not forget to go back and take the opposite. So 12 total split into the opposite of 3 groups. So I need 3 groups. And if I need 3 groups and there's 12 in each group, it's going to be 12 divided by 3, which is 4. So that's 4 in each of these. That would be 4 positives. 12 divided by 3 is 4. So that equals positive 4. And then I have to go back and remember to do the opposite, which is negative 4. So 12 divided by negative 3 equals negative 4. Or another way to write that is 12 divided by negative 3 equals negative 4. So now I want you to take the back side of your paper and we're going to practice. I'm going to model for you what this should look like, and then you will practice on your own. So this is write out the verbal description for each expression, model, and solve. So number 1 is 3 times negative 5. And the verbal description would be 3 groups of, well, that's -5, 3 groups of -5. And then I would model 1, 2, 3 groups. And in each group, I have to have 5 negatives. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 5, 10, 15 negatives. And then there's no opposites, so I don't have to take the opposite of it because my first number is not negative. So it's just going to be -15. So you are going to practice these. I have a challenge for you in number 4. Number 4 is 12 times -11. Now that's going to be a lot if you want to draw 12 groups of 11 negatives. So I would like to see if you can figure this one out with your own model. Is there another way that you could do this using the things that you've learned? Number 7 is where our division starts. And remember, so this is going to be the number that I draw, and this is going to be the number of groups. So I have -8 total split into the opposite of 4 groups. So I'm going to start with 4 groups, 1, 2, 3, 4, and I have to split 8 negatives. So I know that 8 divided by 4 is 2, which means that I'm going to have 2 negatives inside of each group. But I have to remember to go back and do the opposite. So if each group has 2 negatives, the opposite of 2 negatives equals 2 positives. Therefore, this is +2. -8 divided by -4 equals +2. All right, so the rest of the assignment is for you to try on your own. You are going to attempt to do these problems independently. And I just want to highlight that number 4 and number 9 are a bit of a challenge. That's okay. Do the best that you can, and then get your work checked before moving on to your IXL.